Hi, this is Nilton from craftofprogramming.com, and in this video I'm going to show you why you should consider upgrading to JUnit 5. JUnit 5 comes with lots of new features that are not available in JUnit 4, but there are API changes, so that means that you will have to modify your tests to run against the new API. So what I'm going to show you here is the reasons why you should consider upgrading, and given that there will be test code changes. Okay, so basically, as you can see here, there are we're going to cover the awesome new features that JUnit 5 provides, which are not available in JUnit 4. JUnit 5 supports Java 8 lambdas, which JUnit 4 doesn't. And also another point here is that the use cases of JUnit 4 have evolved over time because JUnit 4 has been around for a long time, for many years. And people are using JUnit 4, for example, for integration tests. And this is something that there is no really support in JUnit 4, but JUnit 5, as you will see, have some support for that. Also, there are some changes or improvements in the modularity, particularly in the way JUnit 5 handles the dependencies. There is a new extensibility model, which effectively replaces the rules and the runners JUnit 4 extension model, which we're going to cover, and as well as a cleaner and simple architecture. Perhaps if you're just writing tests, you're not really concerned about architecture, but for people that build tools or IDEs, this is really a concern and something that they will, they pay attention to and they value. We're going to cover also the forwards and backwards compatibility. So JUnit 5 is actually forwards and backwards compatible with JUnit 4, which is a good thing. And this is obviously done by design so that people can transition slowly from JUnit 4 to JUnit 5. Okay, so the new features that JUnit 5 supports are pretty much these are the main ones. So there is a new tag annotation. You can basically define meta annotations, which is your own sort of custom annotations, which are built on top of the built-in annotations. There are nested annotations, repeated tests, parameterized tests, test factory, and display name. We're going to cover one of these, each of these in turn. So tagging tests. So as in JUnit 4, you basically would use categories to do something equivalent here, and this tag basically enables you to just pass a string, and that's how you would tag your tests. For example, here my test, I am basically using the tag slow and tag integration to tag this my test. That's how I would basically tag this. And one other way that you could do the same thing is to define a meta annotation, which is this case here on slow integration test, where, as you can see, we're defining a tag integration and feature to define a slow integration test meta annotation that then you can use in your test. So both ways are equivalent. One uses just the built-in tags, another one uses a custom or meta annotation tag, but both are equivalent. Obviously, if you define the slow integration test custom or meta annotation, then it's more expressive. So this is a really nice way for you to tag your tests, and then you can use these to basically do includes and excludes, just like the way you did for categories. So this is a brand new feature, JUnit 5, and it's less boilerplate code, less code to write, and for similar feature that you have in JUnit 4 for categories. So another new feature of JUnit 5 is nested tests. So now you can actually put effectively inner classes inside of classes for tests, and you can group your tests like that. This might be useful in, for example, the canonical example that JUnit 5 shows is, for example, when you're testing a stack, which is almost a deeply nested feature, data structure, and you can basically nest in with arbitrary depth or nesting level. You can do a nesting like that. So that's a nice way to group your tests when you are actually testing a data structure or something that has this nesting or inner classes structure, and your test is basically mimicking the structure of the code that you're testing. So that's the nested tag feature. Another one is repeated test. So the @repeated, and then you pass a number or an integer, which basically represents the number of times that you're going to run this test. And this is useful, for example, if you are testing some integration test, which maybe it's flaky, and you want to run it, n times. In this case, 42, to perhaps trigger some kind of problem that only happens, after a certain times of runs. I mean, this is just one use case. There are many other use cases for the repeated test, but this is, one very useful case or scenario for the repeated annotation. So another one is the parameterized tests. So as you know, in JUnit 4, you could write parameterized tests, but the parameters tag was applied at the class level. And the big difference from JUnit 4 and JUnit 5 in terms of the parameterized test is that now you can have parameterized tests tags at the test method level. And the other difference is that the parameterized tests in JUnit 4 were a special type of runner. And that meant that you couldn't, for example, use parameterized tests with, say, categories, because they were basically, two different runners, and you could only have one runner per class. So now, the fact that now you can define parameterized tests at the test method level, you get basically two things. Firstly, you can have each test in a class can have its own parameters, sources, as I will show you, and also you can then group now in the same test. You can use a parameterized test, say, with categories, or the similar mechanism of categories, which is the tag that we covered in the previous slide. So in this example here, for the foo test method, we have a CSV source, and basically what that does is, you can see, we're basically passing, in this case, a pair of a string and an int to this method, and we're going to have basically two invocations of this method with those two pairs of parameters. And what you need to understand here is that the parameter types obviously have to match. So the other way you can define a parameterized test is using a method source, which is basically, as you can see, it provides a factory method to inject the parameters onto the test method. And the third one is basically sourcing it from a file. So the other feature is that JUnit 5 supports is dynamic tests. And as you can see, and this is using the test factory tag. And this is a really cool feature, because this basically is creating dynamically on the fly your actual test methods. Basically, there are different methods that or ways to generate. In this case, I'm creating a stream of dynamic tests. You can get a collection of dynamic tests. This is just an example. But the fundamental feature here is that the test body is actually being generated dynamically. And in this particular example that I have here, for each of the values of this string, which is foo and bar, these two strings, I am mapping them onto a dynamic test whose first, here as you can see, whose first argument is the name of the test, and the second argument is effectively the body of the test method. So, and what I'm doing here, I'm just asserting that length of this test name is equal to 3. So this is going to generate two dynamic test methods, one named foo and the other one named bar, and where the body of each of these two test methods is just basically containing this lambda, which asserts that this test name is equal to 3. So as you can see here, this is slightly similar to parameterized tests in that we have a bunch of inputs that we are passing to a test. Here you are actually creating the test body on the fly dynamically. So this is a really useful feature that I think it's something that makes JUnit 5 a very powerful testing framework. So the other one, which is I think it's also a big one, is the way exceptions are handled. So if you recall in JUnit 4, there were 3 ways to actually test exceptions. One is using the try-catch idiom, the other one is using an expected exception rule, or the other one is just tagging the test with an exception that you would expect to be thrown in your test method. So these 3 ways of doing exception testing were basically unified into a single way, and that's how JUnit 5 now tests exceptions. So you basically have these assert, throws, a call here method. The first argument is the name of the exception that you are expecting to be thrown, and the second argument to a third throw is basically effectively the test body. So this is what you are going to test. This is the piece of code that you are expecting to throw this exception. And then a third throw gives you back the exception so that you can then assert the message that the exception wraps. So this basically does everything that we need, right? We can specify explicitly the exception that we expect. We specify the code that is supposed to throw this exception that we're expecting, and then assert throws gives us back the exception so that we can assert the message. So this is a unified way to test exceptions, and it's clean and it's neat and supports lambdas, and I think, in my opinion, it's a nice way to have a uniform, consistent way to test exceptions, as opposed to JUnit 4, where we had those 3 competing ways to test exceptions. Another one, I mean, this is a slightly small one. You can basically now tag or specify a custom test name, and when this test runs, instead of saying complex math, you will actually see 1 + 1 = 2 as the name of the test in the output. And this might be useful for cases where you need that really expressiveness on the test name, which matches the test body. Until now, I've shown you all the new features of JUnit 5 and the reasons why you should consider upgrading. I mean, learning JUnit 5 and upgrading. And that's the point of this tutorial, of this course tutorial of JUnit 5. But one thing that I want to mention here at the end is that rules are not supported in JUnit 5 any longer. I have another, in the next video I will go into the details about rules and runners when I cover the JUnit 5 architecture. But what I want to show here, or I want to say here, is that rules are not supported anymore. So what they have provided is a way to basically support JUnit 4 rules, but as you can see, it's a limited support. Basically, just support external resource, where temporary folder an example of, verifier, and expected exception. So it's a limited support of the existing JUnit 4 rules. And the way you do it is you use this @enable rule migration support tag at your tests. As you will see in the next video, the reason why rules have been pretty much discontinued in JUnit 5 is because they effectively compete with the runners mechanism, and the JUnit 5 designers made the decision to have a single unified extension model as opposed to have runners and rules. So they basically collapse both of these concepts into a single extension model using the extended with annotation. Okay, so I think this ends the all of the features, new features of JUnit 5, and why you should consider upgrading. In the next video, we will talk about the details of the extensibility model as well as JUnit 5 architecture. Thanks for watching.